radical functions class. First, we are going to define radical functions by giving an example. This is the most basic example of a radical function. Remember that a function means that we have one variable in function or depending of another variable. In this case, we have y is depending on the value of x. And we usually solve radical functions by graphing them. Okay? So we are going to make a table to graph y equals the square root of x. We have the values of x, which we can give any values we want, and the values of y that are going to depend on the value we give x. We always recommend that you use negative, positive, and 0 values for x, but we have difference this time and we're going to see why. Let's use the normal values we use. -1, 0, and 1. If x equals -1, what would be the value of y? It would be y equals the square root of -1. What is the square root of a negative number? It is not real. Okay, so we cannot use negative numbers in this type of equations because we don't have any answer for the square root of a negative number. So we are going to add a 4 and a 9. Okay, so if x equals 0, what would be the value of y? Would also be 0. If x equals 1, y also would be 1. If x equals 4, y would be 2, because the square root of 4 is 2. And if x is 9, y would be 3, because the square root of x, the square root of 9, is 3. We have the values for x and y. We have our coordinates. So now we can put them in the plane. We have 0, 0. And then we are going to add the values. 1, 2, 3. Since we don't have any negatives for the values of x, we are not going to be using this part of the coordinate plane. Let's continue with our graph. 0, 0, 1, 1, 4, 2, and 9, 3. And our graph is going to be a little curve. That is the answer to the basic radical function. Now, we had seen in the past that we can move the graph by adding or subtracting, depending on where we put the addition or subtraction. Okay? Now, let's see. If we subtract from the input of a function, we are going to move the graph to the right. If we add, we are going to move it to the left. This is talking about the graph. Now, what is the input of a function? The input is what we place inside the radical. For example, if we add inside the radical a plus 1, we would be moving the graph of our function to the left, okay? It would start in here and go this way. If we subtracted -2, we would be shifting the graph to the right. We would move it 2 places to the right. Now, if we add or subtract to the output of a function, that means outside the radical, then we would be moving it up or down. For example, if we add +2 outside the radical, we would be moving it 2 places up. Okay, so we would start here in 2 and it would have the same shape. If we were to subtract 3 outside of the radical, then we would be moving 3 places our graph down. That is called the shifting of the graph, sorry. And once you see the examples, you will grasp better this, okay? There is also something called reflection of the graph. And for that, we are going to do an example. Here we have our example for the reflection of the graph. We have y equals the square root of -x. Can we have -x? Yes. What are we going to do? Let's check with both negative and positive values for x. If we have, let's change this. Since we are having square root, let's give it a value of 4, negative and positive, okay? What is the square root of -4? We have 2 negatives. This is the square root of 4. This is 2. Y equals 2. It would be the same with -1. 0 continues on being 0, but it would be different when we have y equals the square root of -1. We go back to, we don't have a square root of a negative number. So these two are not real. So we are going to use only negative numbers for the value of x. Now, what do we have to be aware of? We need to take care that the value that is inside the square root is never a negative number. So, what is the value of x when we are talking about functions? The values of x are the domain of the function. So, the domain of the function y equals the square root of -x would be x has to be lower or equal to 0. That would be our domain, because we can have 0 as the value of x, we can have -1, and we can have any negative value. Why? Because when we multiply it by this negative sign in the variable, we would get a positive number. That is the way we can find the domain of the function. Okay, now let's graph it. we have these three coordinates. Let's make our plane. Remember that we graphed y equals the square root of positive x, and the result was a curve. Now let's graph and compare y equals the square root of negative x. We have that we are going to start also in 0, 0. We have negative 1 in x and 1 in y, and we have negative 4 in x and 2 in y. So we have this curve. As you can see, it is just as if the y-axis was a mirror and we have a reflection of our function. That is what is called reflection. When we want to reflect a function in the plane, all we have to do is change the sign. Okay? We place a negative sign. To reflect it on the y-axis, we place the sign inside of the radical. If we want to reflect it on the x-axis, we should place the negative sign outside of the radical. Okay? Let's make the table for this function. Since the x inside the radical it's positive again, we are going to be using positive values for x. Okay? If x is 9, what is the value for y? What is the square root of 9? It is 3. But we have to make it negative. So the value of y would be negative 3. Same thing with 4. What is the square root of 4? It's 2. But after we get the square root, we're going to make it negative. So we have negative 2 and 0 remains the same. Let's graph it. We have that we again start with 0, but this time we are going to go to 9 positive in x and negative 3 in y. Now, 4 positive in x and 2 negative in y. And let's join the dots. And we have a reflection of the same graph, but this time on the x-axis. So, if we place the negative sign inside the radical, we're reflecting in the y-axis, but if we place the negative sign, we are reflecting on the x-axis. Okay, with this, you should be able to do the exercises. If you have any questions, please log into the Facebook Live Q&A. I hope you have a great day. Bye-bye.